So today we are going to discuss sulfur. Sulfur atoms form cyclic octaatomic molecules with the chemical formula S8. Elemental sulfur is a bright yellow crystalline solid at room temperature. So it exists in the form of octamolecule, and its chemical formula is S8. Sulfur contains 6 electrons in its valence shell. Possible oxidation states of sulfur are -2, +2, +4 and +6. The stability of sulfur structure depends on several factors, including the oxidation state of the sulfur atom and the chemical environment surrounding it. The most stable oxidation state for sulfur is +6. The +6 oxidation state is the most stable due to the electronic configuration of the sulfur atom and its ability to achieve a complete octet by gaining or sharing electrons with other atoms. Sulfur in the +6 oxidation state is commonly found in compounds such as sulfuric acids and sulfates. So the most common oxidation state of sulfur is +6. This is the highest oxidation state observed for sulfur under normal conditions. It is important to keep in mind that the chemical environment surrounding a sulfur atom can also affect its stability. For example, sulfur atoms in a complex or coordination compound may have different stability from the free elemental sulfur. Sulfur forms a stable structure. The sulfur atoms form single bonds with itself, creating S8 molecules where each sulfur atom is surrounded by 2 lone pairs of electrons. This molecular arrangement makes sulfur relatively inert because a lot of energy is required to break this stable single bond. So sulfur has a stable structure because each sulfur is surrounded by 2 lone pairs. So it makes the sulfur chemically inert. Additionally, the formation of stable sulfur compounds such as hydrogen sulfide or sulfur dioxide involves sharing electrons in a way that satisfies the octet rule, enhancing the stability of these compounds. Overall, sulfur's stable molecular structure and the energetically favorable nature of its compounds contribute to its limited reactivity under normal conditions. Properties of sulfur. Sulfur is a non-metal and it lies below the oxygen in group 6 of the periodic table. Sulfur can act as both oxidizing and reducing agent. Sulfur's ability to act as oxidizing or reducing agent depends on its oxidation state and its tendency to gain or lose the electrons. Sulfur can gain 2 electrons to achieve a stable electronic configuration like noble gases. In this process, sulfur becomes an oxidizing agent, and it accepts electrons from other substances. On the other hand, sulfur can also lose electrons. So loss of electron is a oxidation. So and exists in +4 and +6 oxidation state. In this case, sulfur acts as a reducing agent because it is reducing agent that oxidizes itself and reducing others. Sulfur as an oxidizing agent. In the following reaction, sulfur reduces from 0 to -2, hence acts as oxidizing agent. Reaction with hydrogen. Sulfur when combines with hydrogen gives H2S, and when the sulfur combines with metals such as zinc and iron, it will give zinc sulfide and iron sulfide. In both reaction, oxidation states of sulfur decreases from 0 to -2. So here there is a loss of electrons. It means that sulfur is 0 to -2, so it means that there is gain of electron, and the sulfur here is reducing itself and oxidizing others, and oxidation state of metals increases from 0 to +2. Hence these reactions represent the oxidizing action of sulfur. Sulfur as reducing agent. So now the sulfur in some cases acts as a reducing agent. It means that it reduces others and oxidizes itself. Sulfur reaction with oxygen. Sulfur burns in air with a blue flame to form sulfur dioxide, and if sulfur is exposed to moist air, it gives sulfur plus water plus oxygen, which gives us H2SO4. Reaction with oxidizing agents. When sulfur is treated with oxidizing agents such as HNO3 or H2SO4, it oxidizes itself and reduces these acids. So S plus HNO3 gives us H2SO4 plus NO2 plus water. In above reactions, Sulfur reduces nitrogen in nitric acid from +5 to +4 and oxidizes itself from 0 to +6. Hence, it behaves as reducing agent. So, sulfur plus H2SO4 gives us SO2 plus water. In this reaction, sulfur reduces sulfur of sulfuric acid from +6 to +4 and oxidizes itself from 0 to +4. Hence, it acts as reducing agent. Now we have the uses of sulfur and its compounds. So there are many uses of sulfur, like it is used as a fertilizer in the ammonium sulfate is a fertilizer and it provides sulfur to the crops, and this is very important for the synthesis of amino acids and vitamins. Gunpowder. So gunpowder typically consists of sulfur, charcoal and potassium nitrate. Sulfur plays an important role in the combustion explosive properties of gunpowder. C7H4O is a charcoal. Okay, then rubber industry. So sulfur is used in the vulcanization of rubber. Vulcanization is the quality of rubber by cross-linking its polymer chain, so improving the quality of rubber. Synthetic organic chemistry. Sulfur containing compounds are widely employed in synthetic organic chemistry. For example, thiol compounds are used in the synthesis of various organic molecules. In the pharmaceuticals, and sulfonyl chlorides are important intermediates in the synthesis of sulfonamides, a class of antibiotics. Dyes and pharmaceuticals and food preservative. Sulfur dioxide and sulfides are used as food preservatives. Sulfuric acid. So sulfuric acid is a colorless oily liquid. Its density is 1.83 gram per centimeter cube and it is almost as heavy as water. It solidifies at 10.37 degrees C to colorless crystals. Contact process, manufacture of sulfuric acid. So the chemical industry makes sulfuric acid by the contact process. The raw materials needed are sulfur, air and water. So the sulfur extracted from the impurities in fossil fuels can also be used in contact process. So the density of sulfuric acid is 1.83 gram per centimeter and it solidifies at 10.37 degrees C. So two colorless crystals. Now oxidation and burning of sulfur. Sulfur burns in air to form sulfur dioxide. Purification of sulfur dioxide. Sulfur dioxide can be purified for further use. Otherwise, impurities present in the sulfur dioxide such as arsenic oxide will poison the catalyst used in the following step. Oxidation of sulfur dioxide. SO2 plus O2 gives us 2SO3. The following conditions are used in this step: 450 to 500 degrees C and 2 to 3 atmospheric pressure. Vanadium oxide is used as a catalyst. Sulfur dioxide is not directly dissolved into water because this reaction is highly exothermic, releasing a large amount of heat. The heat released during the reaction can cause violent boiling and splattering of the mixture, posing safety hazards. So first of all, the sulfur dioxide is made, and after that SO3 is made, and after that we have the last compound, that is oleum. So instead, sulfur dioxide typically dissolved in a different medium such as concentrated sulfuric acid to form what? It's a sulfuric acid or fuming sulfuric acid or oleum. So SO3 when reacts with H2SO4, it will give H2S2O7. The solution can then be diluted with water in a controlled manner to produce concentrated sulfuric acid. Okay, chemical looping combustion, converter and absorber. So here in this diagram we have the sulfur burner, and the SO2 is given to the purifier, and steam is also provided in this chamber, Then this SO2 will react with the oxygen in the presence of vanadium pentoxide as a catalyst at 450 degrees C temperature. So the gas that is evolved is SO3, and here the concentrated H2SO4 will be provided in the next chamber, and there will be a formation of oleum, and after it the solution will react with water to form the sulfuric acid, and it happens in the three chambers. That first is the chemical looping combustion, second is converter, and third is absorber, and the last one is the storage tank. Now we have the properties of sulfuric acid. Ionization reaction. So H2SO4 gives us 2H positive plus SO4 2 minus. Then reaction with base, H2SO4 plus 2NaOH gives us Na2SO4 plus water. Then reaction with metals, zinc will react with H2SO4 to give zinc sulfate plus hydrogen. So the sulfuric acid basically give do the ionization reactions, reaction with water, reaction with bases, and reaction with metals. Reaction with metal carbonates. So when it reacts with carbonates, we give sulfates plus water plus carbon dioxide. Sulfuric acid as dehydrating agent. So it's the best dehydrating agent, and it has a greater affinity for water. So it acts as oxidizing agent. So when we have acetic acid, so when we use the sulfuric acid and the acetic acid, the products will be water and carbon monoxide. And when we have the ethyl alcohol, it reacts in the presence of H2SO4 to give C2H4 and water. Okay, C2H4 is basically alkene. Sulfuric acid as oxidizing agent. Hot concentrated sulfuric acid possesses oxidizing property because of its possibility to lose oxygen. The following reaction illustrate the oxidizing action of sulfuric acid. Hot concentrated sulfuric acid reacts with metals such as copper and tin, and copper plus H2SO4 gives us CuSO4 plus SO2 plus water. In this reaction, H2SO4 oxidizes copper from 0 to +2 and reduces itself from +6 to +4. Oxidation state of sulfur in H2SO4 is +6, while in SO2 is +4. So the 2HI plus H2SO4 gives us I2 plus S2 plus water. Okay. So when the hot sulfuric acid reacts with the metals, it will liberate the sulfur dioxide. And the oxidation state of copper also changes from 0 to +2. So H2SO4 oxidizes the copper and reduces itself, changes its oxidation state from +6 to +4. We have another reaction, 2HI plus H2SO4 gives us I2 plus SO2 plus H2O. Uses of sulfuric acid. Sulfuric acid is an extremely important reagent, and it is widely used. It is very stable and is used in the fertilizer production, chemical manufacturing, in the detergents, paints, dyes, pigments, synthetic fibers. It is used to make plastics, in the car batteries, tanning leather, and cleaning metal surfaces, which is called pickling. So that's all for this chapter. Thank you so much.